I thought I'd introduce functions here by going through what probably may seem like a very trivial type of an example, but still in all, it quite well explains the fundamental concepts of what a function is all about. We've already seen that a function can be thought of in two ways. It's could be described as like a magic box where you put in values x and outcome values y. So that's one visualization of what a function is. It's something that takes in input, it processes and changes that input in some way, and then out comes another value y. So we can say that y is a function of x. X is regarded as the independent variable and y is the dependent variable. In other words, that the value that comes out depends on the value that goes in. Another way of looking at a function is like a mapping process where you take a value and you map it to a new value. So f of x maps all these points, not just one, but all of them, to another series of points. Okay, so that's what the function does. This is what is called the domain. The domain are all possible values of x, and this is the range, which is all the possible values of y. So that's the two sort of concepts, and if you can understand either one, if either one helps you get your head around what a function is, we'll use it and go ahead. So let's have a look at this fairly trivial example, but we'll work through it nonetheless. So a salesperson is paid on a commission basis. She gets a retainer of $500, then $400 for each car she sells per week. That should be per week there. Express her weekly pay, PN dollars. Now we said that you can use any letter for a function. So up here we've got a function of x. This is a function of n. So we use a different letter for different functions. Express her weekly pay as a function of n, the number of cars she sells. So n's the number of cars she sells, and p of n is how much pay she actually gets. So looking at here that she gets P of n, she's going to get the retainer. The retainer is just the money she gets just sitting in the office there, and even if she doesn't sell any cars. So that's always going to be a constant. So that'll be 500. That's always there. Plus, and she gets 400 for each car she sells. So 400 times n is simply 400n. So there's our function for her weekly pay. So this would be an answer in dollars. N is the number of cars that she sells, and P of n will be the amount of money she makes each week. All right, so number B is to explain whether the function is discrete or continuous. Now, as a general rule, discrete involves counting, and continuous involves measuring. So if we're looking at practical examples of functions, if there is a count involved, in this case it's the number of cars, it will be a discrete function. In other words, it won't be a continuous line. She doesn't sell 1.5 cars. She only sells 1 or 2 or 3 or 4, etc. Continuous is where you don't just have whole numbers, but you've got all the values in between, and that's usually measuring. So it is discrete. Whole number of cars. So that's an example of counting when you get whole numbers. Sketch the function. Now a sketch is not sort of it's an accurate representation, but doesn't have to be done. It can be done freehand. So here will be my P of n, and here's my number of cars sold: 0, 1, 2, 3, 4, 5. And when you do this, so this is n, so maybe she sells 6 cars a week. When you do this, it's a good idea to sort of have an idea of what are going to be your maximum quantities, so you know you don't sort of start putting things up through the writing above. So you need to be able to do that. So if we just do it, say, for the first 6, just to get an idea of what it looks like, she is going to make, we put 6 in there for n, 24 plus 5 will be $2,900. So we need to get up to probably around about 3. So maybe we'll just make these in thousands. So this will be 1,000, 2,000. She must be a good salesman if she's making this money. 3,000, 4,000. Okay. And then we plot the points. Oops. Let's just go blue here. So if she sells no cars, she's going to make $500. So we'll put that one there. If she sells 1 car, so it'll be 400 times 1, 900. 2 cars is 800 plus 5 is 1,300. So it'll be there. 3, 12, 1,700. 4, 16 plus 500 is 2,100. What are we up to? 5, 20, 2,500. So about halfway between 2,000 and 3,000 there. And 6 is 2,900. All right, now there's our sketch, and we should put a name on the sketch somewhere. So we've got P of n equals 500 plus 400 n. Now, because it is a discrete function, you don't draw a line through that, because, as we said before, she doesn't sell 0.25 of a car. Don't get too complicated and think she sells a car with someone else, so they split the commission. Just keep it simple. And so there's no in-between values there for this discrete function. So we've done that one, we've done that one, we've sketched the function. Okay, let's have a look. State the domain and range, and I'll put it off to one side here so we can see what's going on. So the domain are all possible n values. And in this case, it's not all values in between, so we need to be careful here. The domain are all x values, and they will be 0, 1, 2, 3, just put enough numbers down so it's obviously what the pattern is, and just put dots, and that means all the values from 0, all the integer values from 0, 1, 2, 3, 4, etc. Okay, so that's the domain. She doesn't sell negative cars, so that's not going to come into effect. 0 is the starting point for this function. The range are all possible y values. Once again, they are values that don't contain in-between values. So here we had 500, and then we had 900, 1,300, etc. Okay, so it's not going to go less than 500, and we're going up by 400s, and that's pretty obvious with the 400 times n. So as n goes up by 1, we're just adding another 400 on as we go. So there's the domain and range. The domain are all possible x values and or the independent variable, and the independent variable in this case is n. The dependent variable p of n, her pay depends on how many cars she sells. So that's D, A, B, C, D, E. Calculate her pay if she sells 3 cars. Well, we've already done that, so but just show you how to write it. So we got P of 3. Now that means I'm going to put 3 in for N equals 500 plus 400 times 3 equals 500 plus 1200, so $1,700. And F, how many cars would she need to sell to make more than 3,000? Now, when you get a question like that, it's simply a matter of seeing how many values of n will give us exactly 3,000, and that's probably going to be a decimal. So then we just always go up to the next whole number. So to make more than 3,000, so we've got 3,000 is her pay equals 500 plus 400n. Take the 500 over the other side and it becomes minus 500, so we get 2,500 equals 400n. So that n equals 2,500 over 400. We can divide top and bottom by 100 by crossing out 2 zeros top and bottom. So n is equal to, now what's that as a mixed number? 4 6s are 24 and 1/4, or you can use your calculator to get 6.25. And so 6 cars is not going to cut it. 6 cars, she's going to be less than 3,000. So to make more than 3,000, so therefore 7 cars to make 3,000 or more. Okay, so we've gone through and worked all the solutions to those questions. Just going back, there's good idea to have in your head what a function is. It's not something magical. It's just something that processes numbers and outputs different numbers. Domain and range. Domain's all possible x. Range is all possible y, or in this case, it was all possible n values here, and this is all possible p values, which are her pay. Be aware that there are 2 different types of functions. There are discrete and continuous. Discrete functions are usually involved with counting. Continuous is usually to do with measuring, some sort of measurement. And values that sometimes you can read off the graph as well. So here we've got calculator pay if she sells 3 cars. Now sometimes when you want to work out the y value from the x value, in this case the p from the end, if we go up from 3 on the graph, then we can go across here and we can read off that value there. In this case it was 1,700. So the other way to do it is when you've got the p value, you can come across at 3,000 and you can see that it is going to be just slightly more than 6, because that'll actually go above the top of that blue point there and come down, and that corresponds to our 6 1/4 here. And you can see that you'd have to sell more than 6 cars to make the $3,000.